Yay! Okay. So, just start.
All right.
Yes. Okay.
All right, you ready?
Yeah.
Okay, I can start. Which of the following variables is R categorical? The number of animals in the local zoo, a randomly selected brand of toothpaste at a convenience store, age and years of randomly selected vehicles in a parking lot, A and B. Categorical. Local zoo. Animals in category.
Oh, I think.
Or would it be?
B, A, and B?
Yeah.
That's what I think.
Okay. A and B sounds good.
Because C is numerical, right? Because that's numbers, the other ones are both.
Yeah.
Okay. Okay, for the mean IQ score of the United States is 100. 20 randomly selected statistics students took an IQ test. The mean of their scores was 112. Which of the following statements are true? 100 is a parameter. Okay. So parameter is like the entire population, and the statistic is the sample of the population. So it would be those last two, right? Because those are both statistics.
Yeah.
Oh,
wait, I don't know. I have to look at definitions again. I need to write those all down.
Okay, a parameter is a true but usually unknown number that describes a population. A statistic is a statistic is an estimate of the parameter obtained from a sample. I don't know, that's hard because it says the mean IQ test score of the United States is 100. But that's, I mean, I don't know if I'd consider that a parameter.
Yeah, I would say statistic.
Okay.
I think your last two is correct. Like putting statistic for both of those, because.
Yeah.
Yeah.
Hey, it's green.
Okay. Number 5. Rotham City has 4 distinct neighborhoods. The property value are very similar within each neighborhood, but they are very considerable from neighborhood to neighborhood. One neighborhood has very low property values and another has extremely high property values. Property taxes are usually roughly proportional to the property values. What type of sample should be collected to gauge the residents' response to proposed increased property taxes? So, just simple random. Maybe simple or stratified. Which one was stratified again?
It says a stratified sample divides the data into similar groups, and a SRS is taken from each group.
I think simple random sample. What do you think?
Well, it's either that. Hey, Green. Well, I don't know. A cluster sample is all atoms in one or more randomly selected clusters or blocks. We are working on number 6.
Okay.
Number 5.
Oh, number 5.
So what'd you get for 4? Mean IQ.
We clicked on the last 2.
Okay. Perfect. Oh, good. I didn't miss much.
Yeah.
trying to open all the readings.
There's like little review, like summaries of in that.
Oh, in the last one, yeah.
Yeah.
I guess everything would be in that one.
We might have to open them towards the end, like, so at the end it's like, this, in this one we talked about this, but it doesn't give any details, so we'll probably have to towards the end.
So,
Wouldn't it be a systematic sample?
no, I don't think so. Because that one's the like every nth. So.
Oh, that's right. That's right.
So we probably want one that represents equally each
Group.
each group. So that's why I'm thinking it's cluster sample or a
Stratified? I was thinking stratified. That was my next guess after systematic.
Okay. So what's the difference between cluster and stratified? Like, why would it be that?
So cluster is all of the items. So the cluster would be everybody, I think. But stratified sample is, so you pick a little bit from each group, and I think it's stratified because every group, and then do the simple random sample after you get each little group.
Oh, okay. So the cluster is just from one group.
Yeah, the cluster would be like everybody in one group, like all of a certain type of thing. So stratified would sound the best.
Okay, yeah, definitely. That makes sense.
Okay.
Okay, I'll read the next one. When design experiments are conducted in a public school systems, researchers typically choose a particular district and randomly select teachers of, say, 4th grade students in that district. The experiment, in which conducted using all the students in a selected classes, which type of sampling scheme is implemented. We just talked about that. So it would be a cluster. Oh. I thought that one, because it's saying from one.
Oh, no, yeah, you're right. I read it wrong.
Okay. I'm like, I got that one. Oh. Okay.
All right. I'll read this one. At a school fundraiser, the name of every person who attended was entered into a drawing. At the end of the evening, 6 names were selected to receive door prizes. Which type of sampling scheme was implemented? The person who attended. So, simple random?
Yeah.
Yeah.
Okay. A special interest group is conducting a survey regarding wolves in Yellowstone National Park. To adequately gauge opinions on both sides of the political spectrum, the researchers took the list of registered Democrats and selected a simple random sample of 100 people. Then they took a list of registered Republicans and selected a simple random sample of 100 people. Which type of sampling scheme was implemented? That'd be stratified? No. Cluster sample? Because it's 100.
Whoa.
Was it, wait. Oh, they selected 100 people.
Yeah.
I almost want to say simple random, but it's too different.
Yeah. It would be
Then would it be stratified random sample?
I think so, because in this summary thing it says the stratified sample divides data into similar groups and then a simple random is taken from each group. So that would be my guess.
Awesome.
Yeah, I was thinking either that or cluster. I'm trying to really know the difference because they both sound kind of similar, but
yeah. My guessing is a cluster sample isn't a simple random sample.
See, this is the reason I think it's cluster is because it's all the items in one or more randomly selected cluster. So.
Yeah, but it's saying all the items. So
That's
this is saying 10. This is saying 100 from 100 simple random sample from a group. That's why I'm
Okay.
stratified.
Okay, I'm down with that.
Does that make sense?
Yeah. Okay.
Yeah. Sorry, I want to go back to that. I wonder if number 6 is a cluster then, because it's saying, okay, yeah, because it's using all the students in select class.
Yeah.
So that would be, okay. I think that's the difference then, using everybody. And okay, sorry. Okay. So a survey was taken of purchases at the Crossroads. Open the data file Crossroads purchase log and use, where is that? Oh.
Where is that at?
I don't know. Did you guys see that? I didn't see that. Maybe it's because I didn't see that before opening.
What? You can't just throw these kind of things out.
I know, that's not nice.
I don't think we've ever had to use something like that.
I think they did once with like the.
Yeah, it was a little while ago, I think.
I think that was the week before I had my new computer in and I couldn't do anything.
I and my only guess is that if we find if we find that week and then, because remember it was like a list.
Oh, that's right.
You would think you would just put the same length in again.
Right.
That would be nice. Oh, Emily, are you recording it?
Yes.
Okay.
I asked her the same thing at the beginning.
I'm so sorry about that.
Oh, it's fine. I don't even know where to look for this.
Yeah, I can't even remember what week it was. What was it called? Crossroads?
Crossroads purchases. Dang it. I thought I almost found it, but nope.
Yeah, I found it. Okay.
Ooh, where is it?
I will put it in the chat. Chat box. Do you see that?
Yes.
Okay,
so
sweet.
It has it in Excel and in SPSS. But I don't know how to do Excel. And then you just have to find it. Okay.
Yay!
Okay, there we go. Now we're talking. Okay.
So we're looking for the mean?
Yeah.
I just
I got 4.771059.
okay. I don't have my thing in yet. I can't.
How many decimal places?
Sometimes I hate Excel.
Yeah, I'm still trying to get my thing in. This is retarded. Oh, good. It let me drag and drop. Thank you.
Ooh, I thought.
And oh, okay. So what are we looking for? Like the using software calculate the mean of this data of the amount. Statistics.
My Excel's like frozen trying to open it.
Oh no.
Okay, what did you get for the mean?
I got 4.771.
Cool, me too.
Perfect. And then let me know what you get for the standard deviation too.
I got 1.99. I mean 1.912 rounded.
That's what I got.
What'd you guys get?
So 4.771 for number 9, and then 1.912.
Okay.
Oh, I forgot how to do a histogram. So you're doing this on Excel?
Yeah.
I don't know how to do it on Excel.
Finally opened.
Good. Where'd it go? Okay, graphs. Yeah, I'm doing it. Sure. Okay. I'm ready to go when you are.
Perfect.
All right. Jessica Meir and her research team measured the body temperature of a sample of diving elephant seals. A thermistor was placed at a specific location on each seal to measure its body temperature. The body temperature of the seal tends to decrease as they dive. The researchers estimated the typical body temperature of each seal at the time they initiated diving and called this the representative temperature of the seal. Thermistors were placed in the hepatic sinus of 4 of the seals named Bodil, Roberta, Larry, and Per. The seal's body temperature at the start of the dive was calculated to be all that stuff. Complete the following table and answer questions 12 through 15 below.
So the X with the line over it, that's the mean, right?
Yes. Yeah.
Perfect.
So what is the value of the number that goes in position of A? So it would be So does it say the mean in there?
I think you just have to calculate it yourself. That's what I'm trying to do.
I got 38.075, so let me know what you guys get.
Okay. What am I calculating? Okay, hold on, sorry.
I got 38.075.
Perfect, that's what I got.
Okay, sorry, almost there. Almost there. You got 38.075? Yay!
Yeah.
Okay, so then we subtract 37.9.
I got negative 0.165.
That's what I got.
Okay.
And I got 0.681 for the next one.
Oh, I just erased. What was the mean? I just erased it.
38.075.
Thank you.
Yep,
See?
I got the same thing as you. 0.681.
Cool.
Perfect.
Yeah.
And that would be standard deviation, wouldn't it?
That is equal to the sum of numbers squared or something. I have no idea.
Yeah, I mean, I'm trying to look it up.
I don't remember ever talking about that.
Yeah, I think it was something small, probably. Mentioned briefly.
Of course.
You can't ask us questions like that. What is this?
Ooh. That's close one. I almost exited out of this quiz.
Oh, that would have been really bad.
Yeah. Well, scared me. Okay. I think I'm going to cheat. I'm going to put it in SPSS and then see what that... I just have an idea. Let's see if this works.
Alright, so I got 7.66. I mean, 0.766.
Oh, sorry. I'm still trying to figure out the...
Number 14.
Yeah. Yeah, I still don't get it. What did you think it was, Kareem?
I thought it was standard deviation, but I very likely could be wrong.
I'm not sure. So I put it all in SPSS and then I did the statistics on it.
Mm-hmm.
And I got, so for the standard deviation it was 0.715 and the variance was 0.511. So I have no idea what's happening. So my guess is none of these are correct because there's only one standard deviation, and then if it's talking about like the different, like the 68, 95, 99.7 rule,
Mm-hmm.
you know, that'd be like 2 to, if it's talking about what 13 is, then maybe that'd be like, see, that doesn't really make sense to me either, so that's my guess. But I don't know.
And I'm just completely lost, so...
Okay. Should we just go
Yeah.
on? Okay.
Yeah, I
I
don't...
think it's either, I think it might be the variance, or it's none of these. Is it none of these? Did you guys say none of these?
Yeah, that's my guess.
Okay.
Because for the variance, I got 1.511. Well, that's not. Yeah, anyway.
Alright.
So did you already get the standard deviation?
Yep. I got 0.766.
Okay, I got 0.715.
I'm gonna double check my numbers really quick.
Yeah, I'll double check. Because I'm totally wrong. Man, I have too many windows open.
Oh, hang on. All right. Yep, I had dyslexia going on. It is 0.715.
Okay, cool.
Under certain conditions, the standard deviation can be negative. False.
Right? I thought it was true.
I thought it was false.
Isn't it? It's the average distance away, so there it can't be a negative distance
Yeah.
from a number. So it's always going to be positive.
Okay. Okay.
At least that's how I understood it.
I just thought that I was, you know, remember like that, the applet that we were putting in?
Mm-hmm.
Like, I just thought that was the,
But that finds the z-score, and then that gives
oh,
you.
that's the
always
Z
gives you
score.
a positive
And
number.
that's yeah.
Okay, yeah, you're right. Because I was thinking of the Z score. But it's okay, yes. Okay, so it's false.
Yeah.
Okay, I'll read the next one. In the same study, the researchers placed their misters in the three seals. Check Stuyvesant near their spinal cord and brain in the external vein. They placed their misters in 6 other seals. In their aorta, the largest artery in the body. Finally, they placed their misters in the other 4 seals in their hip. Science. The results from this study are summarized in the table below. Which location resulted the most consistent temperature measurements in one seal to another? The extradural, because it has a smaller standard deviation.
Yeah.
Yes. Yep.
Does somebody want to describe the
True. We just did that. So the average distance from each sample from the mean. Yes,
Yeah,
the mean.
Yeah.
that's what. Yeah. Awesome.
Okay. The number of hours students spent studying for an exam were recorded. The data are represented by the box plot below. Use the box plot to answer 19 and 20. What is the third quartile? 8.
Ta-da!
Cool. What percentage of the data lies between 4 hours and 8 hours?
1, 2, 3, 4, 5.
60%.
Isn't that 40?
I don't know. That's. Hold on. I have that up. So where are you getting those numbers from? Can you explain this to me? I'm confused.
I know. I think I'm thinking too hard.
Okay, so Okay, so if 4 is the first quartile, do the quartiles have to do with the 60,
That's what I
95?
was wondering, because I think I put 68% because it'd be, but I don't know if that's just one. I don't know.
Yeah. Okay, so minimum, the first quartile.
6 mean.
So where's the quartiles? Um, okay, so this is. So the percentage between the first, we're trying to find the percentage between the first quartile and the third quartile, and then all it says is that, all I can find is that the quartiles are, oh my god.
Oh wait, it's 50%.
Oh, is that it?
Because so it's the median and then the first and the third quartile, they're the medians between. So am I making sense?
Yeah.
I feel like okay. So
No, yeah. Okay.
Okay, yeah. So the quartiles divide a sorted list of data into 4 equal groups, so each group contains 25% of the data.
Cool.
Sweet. I think we overthought that one too much.
yep.
Awesome. I forget. Is it my turn?
Sure.
Okay. An observation from a normally distributed population is considered unusual if it was more than 2 standard deviations away from the mean. There are several contaminants that can harm a city's water supply. Nitrate concentrates above 10 ppm parts are considered a health risk for infants less than 6 months of age. The city of Rexburg reports that the nitrate concentration of the city's drinking supply is between 1.59 and 2.52. And values outside this range are unusual. We will assume that 1.959 is the value of the mean minus 2 standard deviations. So within 95% is equal to, okay, it's reasonable to assume the measured nitrate concentrations. So 21. Estimate, sorry. Estimate the mean of the measured nitrate concentration in Rexburg's drinking water. Okay. Okay.
So
Okay. I'm looking for the median.
Is it just 1.59 plus 2.52 divided by 2?
Oh my goodness. I think so.
I got 2.055.
So let me do that really quick. Oh, turn on.
But I don't know if that's what it's really asking for or not.
Yeah, I'm not sure.
I'm pretty sure that's because mathematically that makes sense with the mu minus 2 theta and mu plus 2 theta. So it would have to be in between the two of them.
Yeah, like my little graph.
Whoops. Yeah, so I got 2.055.
Uh,
Okay. I feel like it's harder than that, but it's really not, right?
that's what I'm thinking. I feel like it's asking for something different, but don't really know what it's asking for. So
Yeah. Is it possible to find the standard deviation from that? Because we need the mean to know the standard deviation, right? That's the next question.
I hate this class.
Yeah. Okay. Okay, so
Have you found that in the text?
no, I think quite.
I don't know how to do that.
So I did an equation. So like I did. So I did 1.95 equals the mean that we got, which was 2.055 minus 2 theta. And then I solved the equation for theta, and I got 0.233. And then I put that back into the equation and got the same answer. So
That sounds right. I can see that.
Very good. Yay!
okay. So you think that's right?
Yeah, that's
Yeah, I think that's
definitely legit.
Okay.
At least you had a reasonable way of doing it. It sounded good. So.
okay. So it's 0.233.
Beautiful.
Yeah. So hopefully that was right. I'm so confused how we got 21, but we'll just.
Well, I don't know if that's really the mean. I just don't know how else to do it.
Yeah. I mean.
What's the first number again? For the it's something 68 and then 99.7.
What?
What?
For the one rule, so it's
68,
number
99.7.
Yeah, it's 68, 95, and 99.7. Is that what you just said? Yeah.
okay.
Yeah.
Yeah, I think that's right because
Oops.
I made a little chart. Oh, it's backwards. It works. I'm pretty sure that's right. Oh, sorry, we're on the next one.
Yeah, we did it right because this is coming out perfectly.
Okay.
It's the last one. So if you add one standard deviation to the mean, then it's 2.288.
Yeah. Okay.
Yay!
Yay. Cool. That works. Okay.
So what is the mean of a standard normal distribution? What?
Oh, what was 23? Just kidding. Okay. What does it mean average standard? One? Zero? I don't know. What does it mean average
What
standard?
number are we on now?
24.
What was 23? Sorry.
The last one.
Yeah.
Okay.
What does it mean?
Standard normal distribution.
Is that a trick question?
1.
Yeah. I mean, I don't.
What is the mean of a standard normal distribution? One? I mean,
I think it's 1.
alright, we'll go with it.
Because I think that's just trying to trick us, because I don't know.
What is the standard deviation of a what? What?
Okay, so this is gotta be in the homework, right?
Shoot.
Okay, the only thing I can find is this thing that says that everything under the... Where'd it go? But this is density curve. Is it the same thing? No? Probably not. The only thing I can find, it says, okay, so it says, so it's talking about the density curve, and it says the total area under the curve equals 1. But that doesn't help us.
I don't know why you'd give us these kind of questions. Like, we've never talked about anything like this.
Yes.
You guys want to come back to it later?
Yeah.
We can do the stuff that we know
Yeah.
Yeah.
right now.
All right, the admission committees for the most Masters of Business Administration program require the graduate management admission test as part of the application for new students. It has been shown that the scores on the GMAT are normally distributed within a mean of 542.3 and a standard deviation of 120.54. The minimum GMAT score required for admissions to MACC program at the School of Accountancy at BYU is 500, but it is rare for students with score less than 600 to be admitted. Use information in answers 25 through 31. What is the probability that a randomly selected student will score above 542.3 on the GMAT? Round to the nearest tenth.
So do we need to use the applet for this?
That's what I was thinking.
Now I have to find the link to the applet. Oh, I found it. Do you need it?
Ooh, can you put it in the chat thing?
Yeah. Did it work?
Yes, thank you.
Okay, now what do we put in there? Oh, do we have to find the z-score?
Yeah.
Okay.
All right, how do we do that again?
Okay, we subtract the value from the mean and divide by the standard deviation.
So, are we going with 5 or 600?
So I think we go with the 542.3.
That's the mean, though.
That's the mean.
Oh, above.
Oh, I think it's 500. Yeah, I think it's 500. So 500.
I don't know. I think that's still the. I know that's the mean, but I still think that's the value too. Which
Well, then it would just be
zero.
then.
You can't put 0 in there.
Yeah.
So 500.
So I got 0.351.
Okay, hold on. What was the standard deviation? 200, 100, 200.5.
And what's it asking? Above. Okay. Then I got 0.3628. So 0.363? Oh, no.
So what numbers did we use for 26? 500?
Yeah.
So what did you end up getting on that one?
Let me look again. 0.351.
Okay. Because I know that'd be right for the 600, but I'm still trying to
And
figure
then
out.
would it just be 0.4 then?
I thought 0.351 is a z-score. Is that?
Yeah.
And then
And then I got 0.4, because it says round to the nearest tenth, so then it'd be 0.4 for probability, wouldn't it?
sorry, what was that?
Since it says round to the nearest tenth, it's coming out to 0.3628, but so
Yeah.
it would be 0.4 then.
Yeah. I'm still. That's what I got, but I'm still not sure.
I'm just not sure if we're using that 500 or not on that one.
Yeah. 'Cause
Like
it
the
doesn't-
next one, it's obvious we're using 600,
Yeah.
but
I'm confused about that. That's my thinking too.
So I got the z-score 0.479.
yeah.
Whoops. Whoa, no, stop. So 0.3 is what I'm getting for the answer.
Well, that for the wait a sec.
No. So you're getting 0.316, is that what you said?
Mm-hmm.
For which one?
For 27.
Yeah. Wait, does he want the 10th again, or? Oh, 3 decimal places. Just kidding.
Yeah, I don't know why he switched for that one. I don't know. I haven't put anything for 26. I might go back to that. I'm confused. So let's score above. Oh wait.
You guys say you got for 27 again?
So I got 0.316 for 27.
But I was thinking, would it be both the middle and the end because the z-score was the positive? So then it might be 0.684.
Oh, if we...
I got 0.681, so that's why I asked. I might have did it wrong. I don't know.
Well, that's what. Yeah. Did you put 3 decimal places in
Yeah.
for the z-score?
Yeah.
You say 0.479 for the z-score?
I put 0.470. And then I got 0.681 for number 27.
That might be why ours is a little different because I put like what Corinne said, I put 0.479 as my z-score. And then if you do the shaded in the middle and the side because the z-score was positive.
Yeah, so you got 0.684?
That's what I got too.
Okay.
Okay.
Okay. Score above 600. And then 0.316 for 28.
Yes.
Yeah.
Almost done, guys.
Woohoo.
So
How do we do that?
I have no clue. Wait. Maybe I do. Would we input 0.1 on the top?
And then convert the z-score to...
Then we could find the z-score. So it'd be x minus 542.3 over 120.54 equals 1.282.
Okay. Yeah, let's do that.
So I got 697.
I did too. But that seems like really... Oh, it's 10%.
So what formula did you guys use to get that?
So the formula that you used for the...
We're solving for the value. Yeah, so the formula that we use for the z-score.
Okay. What are you doing? Your project. Might have one.
Wait, did I do that backwards?
Let me see.
Oh. Wait.
What class is that for? Stats.
Corinne, did you start doing number 30 and then get confused?
Yeah. So I think would 90th percentile, that would be where we start out shading the right side, wouldn't it? And then for the 10th percentile, that's the one where you would shade the left side. So I think it's the difference is using the negative and positive z-scores. So I think 90th percentile, I think that one is what I calculated for, so I got them mixed up basically. What was the whole number that you got though?
The value for x?
Mm-hmm.
I got 697.
Okay. That's what I got. So over the 10th percentile.
Oh, so that's the 90th?
Yeah, so that would be the 90th. So that's at the higher end. And the lower end, we need to use the negative z-score instead. So
Okay. I vaguely remember reading something like that, but
okay. So
then so
So I got 388. Let me know what you come out with.
You said 388? Yeah, that's what I got too.
Perfect.
Okay, so percentile meaning, so because it's in the 90th percentile, that means you scored better than 90%.
Right. Yep.
So wouldn't that be the higher number though?
Yeah.
Oh yeah, okay.
So 30
Yeah.
would be 697 and 29 would be 388.
Right.
Okay.
Yeah. Yeah.
Okay.
Okay. It makes sense.
Yeah, that. Find the first quartile of the distribution of GMAT scores.
So could we add one standard deviation to the mean to get that, or
I think so. Or subtract one.
Yeah.
So,
You guys get 41.76.
Yep. So the whole number, so 422.
yeah, that's what I got.
Okay. Sweet.
And then just this opposite.
So I got 663.
Yep.
Lovely. What?
Oh, okay, so this one, I think we have to do the square root of n.
Yeah.
Yeah. What's... do you remember what lesson that is? I want to double check.
That's what I'm looking for the exact formula of it.
Okay.
It's lesson 7.
Okay.
So it's value minus mean divided by standard deviation divided by square root of n.
I want to say that one more time.
So it's value minus mean divided by standard deviation divided by square root of n. And so n would be 15. So it'd just be...
So we're still... Let me see. What is the mean of the distribution of the sample? Okay.
So.
Oh, the mean is still...
Yeah, mean's still 542.3.
Yeah.
But
I'm assuming that we would use 500 again. Since it's not giving us one?
yeah.
For what number?
For 33. For the sample.
So yeah, I think it's 500 minus 542.3 divided by 120.54 divided by square root of 15.
Okay, well
Does that sound right?
that's the z-score. It's just asking for the mean, which the
Oh.
mean is the same. Since
Yes.
it's a normal distribution, then the mean is going to be the same.
Yeah.
So it's 542.3. Right?
Yeah.
Whoops.
But then the standard deviation is going to be 120.25 divided by the square root of 15.
Okay. Yeah, you're right. You're right. Yeah, I was doing the whole z-score thing.
Yeah.
So 120 divided by. I got 31.123.
Me too.
Perfect. Woo, last one.
What is the probability that the sample mean GMAT score of SRS of n equals 15 students will be greater than 600?
Okay, so now we do that long equation
Yeah.
to find the system, right? Okay, so it would be 600. Okay, so for the z-score, I got 1.854.
Yep.
Hang on.
And I got 0.032 for the answer.
Me too.
Perfect.
Okay. So I didn't do 26.
So with 26, are we just going to go with it's 500 for?
Yeah.
Cause I don't know what else it'd be, and I guess because it's asking for 600 later on, then
Yeah.
Would
I mean,
it be-
that was my thinking too.
So maybe since that is the mean, do you think the probability is 50%?
yeah. Score above 500. Yeah, so it'd just be 0.5.
That's my guess.
That actually sounds pretty right.
Yeah, it does.
So
But at the same time, the mean is not the median would be the middle. Nah, never mind.
yeah,
I don't know.
that's just my guess. I don't know if it's right, but to me it doesn't make sense to do the 500 because you're supposed to put in the value that it's asking for, but
Yeah.
I don't know. Okay, so what does the mean of the standard normal distribution?
Oh my gosh. I'm gonna say 1 because I have no clue.
I think this is so stupid. Okay, I'm gonna Google it. Yeah, let other people Google it. The standard deviation. Oh, it says a standard deviation a standard normal distribution is a normal distribution with a mean of 0 and a standard deviation of 1. So I'm just going to put that in because.
So it's 0. So would number 24 be 0 or would it be 1? And then 25.
So 24 would be 0 and 25 would be 1. So this is here. I'll paste. That's what I googled. So that's what came up.
I like it.
All right. Let's see how good we did today.
Okay. Oh my gosh.
Wait, what? What did I not do? I did all of them.
So what did you guys get a B 89?
89%.
Yeah. Okay. So.
Oh, what did we say for 3?
Oh.
We said A and B.
Okay.
Oh.
Oh, the number. Oh my gosh.
That one tried to trick us. That's stupid.
That's retarded. I didn't see number. Oh, dang it.
I think we just rushed through it because animals at the local zoo. We figured different.
Yeah. Dang, that's retarded. Okay.
So we didn't do the first quartile and second quartile, right?
Okay, and I was wrong about the United States. I guess that is a parameter.
Yeah.
Okay. I was thinking it was a trick question, but I guess it wasn't. Okay, and so I guess I need to find out how to do court. Maybe I'll ask him at the.
I'm gonna look at what is it. You guys, wait, you didn't get that right?
Which one?
The
31
number.
and 32.
Oh, hang on, let me look. Oh yeah, we got those wrong. Okay. I was looking at the quartiles before this one. Okay.
So we got 3, 4, and 31 and 32 wrong.
Yeah.
That's better what I've been doing on my assignments, so I'll take it.
Yeah, I'll take this over all of them.
As long as my grade's moving in the right direction.
All right. You guys have a great night.
You do this.
Okay, me too.
Good job.
Good job.
All right.
Okay, I must stop.